Okay, I wanted to make a video for this question. This is the number 5 from the 2011 AP Statistics free response portion. We've done questions 1, 2, and 5 together, and this one applied directly to what we're doing right now. And I gave this to third period since we had double block, and I was a little surprised to see that so many people, despite having seen this question several times, had forgotten how to read this particular table. Now, if you are having trouble, there's a little section, okay, it's called Regression on the Computer on page 188 of your textbook that says, the slope and intercept coefficient are given in a table such as this one. Okay, you can see that on the screen. It's almost identical to the one in the book. And it says, usually the slope is labeled with the name of the x variable and the intercept is labeled intercept or constant. So when we look here at this data, it's saying for part A, use the computer output above to determine the equation of the least squares regression line. Alright, if you look here where it says constant and then it says coefficient. Now again, I know that doesn't really make sense. Usually we think of a coefficient, okay, being the numeric value with a particular variable, but in this case it is saying it's constant, meaning there's no variable representing the y-intercept. So in this case the y-intercept, b sub 0, is 0.137. Now as it said in the book, the x variable is listed with the slope, so wind velocity is the x variable. Okay, the slope is 0.240. So then the equation would be, now keep in mind that what we're trying to do from the setup of the question is we're trying to predict electricity production. So we'll just call this electricity hat equals 0.137 plus 0.240 wind velocity. That's it. It says to identify all variables used in the equation. Well, again, there's only 2 of them. Okay, there's electricity production that's measured in amps, and there's wind velocity, and that's measured in miles per hour, and that's it. Now it says how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when the wind velocity is 15 miles per hour. Well, there are 2 ways you can do this. You can take that prediction equation, you can plug in 25 for wind velocity, 15, and you can just subtract and find the difference. Or else, you can interpret the slope and just use the slope. The slope of 0.240 says as wind velocity picks up by 1 mile per hour, the electricity production should increase by 0.24 amps. So the difference between 25 and 15 is 10, so we're picking up 10 miles per hour. So if we're increasing 10 miles per hour, that means that we're going to produce 2.4 additional amps of electricity. And that's all you have to do for part B. When it says what proportion of the variation in electricity production, which is y, what proportion of the variation in y is explained by its linear relationship or its linear model, okay, or by the variation in wind velocity, we've talked about this, is simply the r squared value. Don't worry about r squared adjusted, just worry about your r squared of 0.873. That is the proportion. If you would like to give that as a percentage, it's just 87.3% of the variation in electricity production is explained by the linear model. And that's how you would answer parts A, B, and C. Part D, is there statistically convincing evidence? We're going to learn in the upcoming chapters how to do this. We would just want to make sure where we are at this point that we're not assuming that a good model or a linear association means a cause and effect relationship. Okay, so kind of disregard part D. And to go back to part C, we talk about what proportion of the variation. Again, it's not saying is the model appropriate, it's just asking for the proportion, which is a way that we measure strength of a model in terms of the variation of y accounted for by the model of the variation in x. So just listen to this, kind of read it, pause the video where necessary, but make sure you're able to understand this table, read it, and then determine the equation of the least squares regression line. Remember, it's the same thing as the line of best fit, same thing as just the line of regression or the regression line. Those are all the same term or different terms for the same idea. Hopefully that helps.